Hello guys, this is the Impeccable Robot Simulator IRS. We are doing a ADAS focused driving simulator game that is focused on the robot starships around Oregon State University, where you play as a starship robot and you'll be delivering food. And I'm Connor, I did the ADAS stuff. We got our boy Kevin.
Hey guys, I contributed to some of the smaller tasks that the team needed.
Hell yeah. We got our boy Riley.
Hi. Yeah, I did a lot of the modeling and Blender map work, and then the UI.
That's why everything you look at is beautiful.
That's so true. Okay,
and Kevin, do you want to give your explanation of what you've been working on?
Oh yeah. I didn't work on anything about
real. This is Connor. I did the ADAS stuff, so if you can hit the play button, thank you. Once it's done loading, we will see my implementation of raycasts. This is how we're going to fake the LiDAR sensors. Obviously, we can't do a real simulation of them, but we have 4 sensors, one in the front, left, right, back, and depending on which one gets triggered, that will cause different behavior. Like obviously, if there's an obstacle right in front of you, the robot will stop. Which we can show right now. Like, it won't let you run directly into people, which is pretty accurate to how the real robots act. And you can see on the right, we've got that beautiful display made by Riley that will just instantly report where it's seeing obstacles. And hopefully in the future, we've got a vision that it will be distance sensitive. So each of those bars will light up as something gets closer. And then you can get a little bit more detail going on. Each of those calls its own event. If we can pull up the code. My code was... This has been what I've spent most of my time on. It was very messy, very wacky from the start, but I have since reorganized it and made it very legible and understandable.
So this is Connor from the future, and I have added a lot of comments to the code to explain what's going on. They go into detail for a lot of the individual variables, but a lot of it is pretty self-explanatory and laid out in a way that I think is logical. Just going over it real quick. It starts with a lot of variables. These are defined by the game engine, so these values defined here are actually not accurate at all. It allows us to tweak them on the fly and get the right shapes that we want. The steps and the tops and maxes, those are for defining the number of rays that get cast per chunk and the boundaries for which it will cast. So that way we can kind of get the shape that we want if we ever want to change it in the future, as well as make it higher or lower resolution, because that affects the performance of the program pretty heavily. When you're casting, I don't know, maybe 100 or so rays constantly, that does tear into your performance just a little bit. And so if we want to do some optimization, we can make it less granular, and that helps a lot. So when the script first wakes up, it will grab an instance of the player controller. So that's how it will interfere with your steering. If it thinks you're about to drive off a cliff or directly into an obstacle, it won't let you do that. Then this chunk of the code is the part that actually casts one of those trunks that you see in the player demo. It does a bunch of cool math that I don't remember how I did, but took me a very long time to figure out. This is what I spent most of my time learning and developing throughout my time. I didn't understand quaternions going into this, and now I still don't, but I got the code to actually work. It casts the rays by starting at the top, and it casts a line, so it does some sine cosine nonsense, and it will cast one at the very far left, then a little bit to the right, right, and then it will go down by whatever defined angle we have given it, and it will shoot another row of them, down again, another row, down, another row, and that's how we get that sort of it's like a semi-circle chunk that we see when we're actually playing the game and revealing the casts. This last chunk of the code is very simple. It's what just does the directional and spatial offsets. So the shape of the starship is not a perfect square or circle. The sides are closer to the center than the front and rear. So the point that the casts on the sides have to start from is closer than the ones in the front and back. And that's where this is all defined. This also does each of the angles, because it's 90 degrees, 90 degrees, 90 degrees. trees, and that's where this is all defined. And then if a hit is found in any of those chunks, it will update the UI element that Riley designed, and it will also perform the necessary evasive maneuvers depending on the direction that it sees an obstacle. In the future, we would like this to be distance sensitive so that it is not just immediately braking when it sees something in front of you. It's more reactive and natural. Granted, the real starships are not very natural. They often stop in front of you and do weird stuff, which is kind of what we want to emulate. We want it to feel like the actual Starship robots, but it would be nice if it was less invasive and more practical for actually getting to your destination.
Nice job. This is Riley. I did a lot of the map, as you can see. If I turn on the lighting, the current FPS is a little bit not the best, but we're working on that, messing with some scripts, and I'll probably bake the lighting in as well once the map is more full. But the Blender part is pretty much done. We went with just kind of a smaller, hopefully more detailed map, as the expo won't be having a whole lot of time for individuals to play for tons of time, so we wanted to keep it short and sweet. We went with Dixon, Weatherford Hall, Moreland, a couple of dorms, and the Dutch Bros, which is the starting point for the actual game. Used Blender a lot, as well as getting the textures from actual pictures. For example, there's pictures, even I'm in the picture, as you can see, for
That's awesome.
textures on the side of buildings, which is kind of goofy, but they do look at least somewhat realistic. And some of these models, like the trees and things, were free online models that we can get, so we can just add more detail in the scene and hopefully make it feel more like the campus. So if we go into play the game, the other kind of big stuff I worked on was the actual UI.
Not to mention the robot.
I modeled the robot too. That's a good point, which I could show in Blender, but it crashed, so I can't show it. You can see it here anyway. And so right here on the left side, we have a temperature gauge, which is basically on a timer system. So there's a certain timer that we're currently adjusting to see what's the right balance. But after, say, for example, 100 seconds, this will eventually be empty, and your food would be cold, and you would fail your delivery. Now, the bottom left-hand corner is a robot's kind of health bar or like repair bar. So if you run into a pedestrian, then it starts to go down, and if you run into enough people or vehicles or trains, then you also fail your delivery. We've mentioned this already, but this is the ADAS display, just getting the information from Connor's script and applying that to kind of change these colors whenever they're active. And lastly, this current objective is also displays the current pickup. For the expo, it's pretty much set to be 2 locations always, but there are other options that we might change. And now I'm going to run into...
You should hit a car.
As many people. The car's too far away. I'm going to run into a couple more people, maybe one more. I should. There we go. So this is the final delivery score screen. We just have a simple like star system, which if I go into the script... score handler. I kind of have this janky calculation long function here that is just dependent on what your health and temperature bars are at whenever your delivery is complete or failed. If you fail, you're going to get 0 stars anyways, but theoretically, if you were to complete it on time and with a good temperature, you could have 1, 2, or 3 stars here, and it would display your time that it took to actually do that. As well as these 3 buttons, go to main menu, and the restart button, resume, so you can restart again. One other thing I wanted to show was just those buttons also are controlled through scripts. So to pause the game, you can escape. That's for the escape key. And this is kind of like through Unity's way that they do things, is you kind of pause the timescale and set these different panels active, so like pause and gameplay. And these are how all the buttons are handled in here. And then I could show there's just a simple pause screen that you can use for different things. So hopefully we still have some ideas to finish up the map, add some kind of more aesthetic things, maybe switch up a little things with the UI, and lastly I want to add a tutorial or just a little like descriptive for the people at the expo, because just when you first start, because you won't know what the heck is going on with all of this, so just some little text bubbles probably be good. But yeah, that's all I have for me.
Hi, this is Ethan, and for our project, I was the one that did a lot of the stuff that didn't have to do with ADAS or the graphics or the UI. So that left me with doing the player controller, all of our pathing system here, and then our delivery system. So the player controller you saw Riley demonstrate earlier, and so we'll go through the pedestrian paths. We can see all of the pedestrian paths on the map. If we click on this object here, it has no scripts attached to it, and then we can see each different block section. We can click on the east side and we get just these paths. The south side is down here, and we have each of the areas is blocked out. And then if we open one of these guys up, we get each individual path. So we got east, the lower section of the east section going to Dixon. And this also doesn't have a script, but once we open this guy up, we get the path in that area, and that path does have a script, and each path has a bunch of nodes that make up that path. And then there's a spawn at the very start of the path that spawns in these pedestrians that have scripts on them that cause them to walk on the path, and once they get to the end of the path, just happened there, but they'll despawn, and new ones are constantly spawning in. And we also, this spawner has a minimum and maximum spawn, randomized spawn, and this is the minimum and maximum numbers it could be. And that is the exact same kind of system that the cars are using and the train, but just all of the spawn rates and of course the speeds are slightly different. So that's what we got for the pathing. And then for the delivery handler, this has a script. This gives the deliveries to the player, and then this script here makes it so that you can visually see and easily just add more start and end locations by putting these empty objects inside the start and end locations. We have an expo mode, I think, on the delivery handle. Yeah, expo mode is on, so that will cause every delivery to start at Dutch Bros, this first object, and end at the corner of Buxton over there, so that our players during the expo will all have the same experience driving from one corner of the map to the other, and then the game will also end at that point. Whereas if they weren't playing in the expo mode, they can continue playing and they'll get a new delivery to go to a new location. But we want the demo to be short so that as much people as that want to play the game can end up playing it. That's what we got in the scenes here. I made my scripts a little simpler and went for an approach where you can do a lot of the creation in the editor itself, in the scene editor for Unity. So I'll go into the scripts that we do have though, because there's still quite a bit. In the player controller, we have maximum acceleration, current acceleration, and then these variables are used to track the ADAS. These tell us if the sensors are being used, and then these alter the movement based off the sensors. Here we initialize things, and this is a sprint variable. I skipped that one. But check warnings. Every frame we check for warnings, and these warnings will alter the movement of the robot depending on what kind of warnings are being sent. Warnings get sent through RayCS. We added these little lines that tell the robot what sensors are being hit. This is the front sensor. If it gets hit, we set a front warning to be true. If it isn't, we set it to false. So then depending on what warnings are set, this will act accordingly. That will happen first, and then we will alter the UI element that displays the ADAS. That's Riley's doing there. And then we have the brake and the sprint, and then here we set the right drive track acceleration and the left drive track acceleration using the two modifiers in the ADS. The max acceleration that we set ourselves ourselves, and then we take in the user input and the robo boost that is also user input. We'll set the right one, the left one, we'll apply the brake to everything, and then we will update all of the wheels with the numbers that we found. And that all happens in here, where we rotate the wheels in order to move the robot, which makes it more of like a realistic physics-based system. So yeah, that's it for the player controller. And then delivery editor, this is mostly just so you can visually see everything in the start and end objects. Here we gather all the start and end objects, and then we see what state the player is in their delivery, and change some of the UI elements accordingly and give them new goals depending on where they're at. And we have an expo mode here where we give them the first start and end location, which is Dutch Bros and Buxton. This one we do random one instead. Here we set a waypoint for them to see where their end location is, and then there's this section here for when they fail the delivery. And then from there we have drive on path, walk on path. Those are very similar, and then the two path editors are also very similar. So I'll go through the pedestrian version. Here we have the walk on path that takes in a path, which is the path that they're working with, and then they'll have a current waypoint that they start at, and they'll look at that, they'll find their next waypoint, and then they will see the distance they have to that waypoint, and then they will move towards it. They'll look at the rotation they have towards it, and they'll look at it, and then if they're close enough to the next waypoint, then they'll start going to the next one, so they have more of smooth turns around corners. And if their next one doesn't exist, then they just get destroyed, or they despawn because they've gotten to the end of the path. That happens both with pedestrians and cars. And then for the pedestrians, it's for their paths, they get a spawner created at the start, and the spawner has a randomized time here, and then a spawn rate. And then here it visually shows all of the elements in the path and makes sure that they're there, because these are the exact same elements that will get worked with in these path OBJs that it gets from its path. So that's everything for the scripts, and I believe that was everything here. All the deliveries. There's more behind the buildings, and we got all the paths, and we saw the player controller in action during Riley's demo. So that is all that I have done for this project.
Alright, this is Kevin. So for my part, this spring term, I mostly worked on implementing a radial graph for our game UI, or at least an early iteration of the game UI. The purpose of the graph was to be a visual representation for ADAS collision detection. So in a specific direction, if there's collision potential, the game UI would light up. That specific portion of the UI would light up. And so for us, we wanted to plant the vehicle, kind of a little miniature vehicle picture on our game UI, and then around it would be a graph. And so the graph, there would be multiple planes on the graph, coinciding with a specific direction. And so the goal was to have that direction light up depending on where the vehicle detected collision potential in the game. So very simple. And I had a janky iteration of it in the beginning, which was just to take a Google radial graph and then cut and paste all of its corners, its planes, and then paste it into our game. Put a little picture of our vehicle in the middle of it, our little Starship in the middle of each graph's sides, and then just kind of make it light up anytime the vehicle would detect it. So we would have a script, and it looked kind of janky. It didn't look the best, so the new iteration looks a lot better. But yeah, I mostly just worked on that, finding ways to kind of get that figured out. Towards the end of the term, I just contributed to smaller tasks. For the last 2 weeks, I'm going to be just detailing the map a little bit, finding objects online, and adding more to our map. I also worked on the landing page this term, so yeah, that's kind of my contribution this term.